Today we're going to talk about finding the area of a regular polygon. In previous lessons we discussed the formula for that, which is area is 1/2 the apothem times the perimeter. So this is the formula for any regular polygon. A regular polygon means that all the sides are the same length and all the interior angles are the same length. So in this example we have a regular polygon. So again, area is 1/2 the apothem times the perimeter. Now the perimeter in this shape, since each side is 8 and there's 5 sides, 8 times 5 would be 40. Alright? So each of these sides is 8. Now the apothem is this segment here, CY. That's from the center down to the middle of that side, the midpoint of that side. It's also perpendicular with that side. Okay, now first thing I'm going to do is I'm going to use one of these right triangles over here. I'm going to use this triangle CYX. First thing I'm going to do is I'm going to find that angle right there, which is 360 divided by the number of sides and then divided by 2. And to do that, you get 36 degrees. Okay? This side XZ, alright, is 8, just like every other side. So that means the bottom of this triangle XY is half of 8, which is 4. Alright, since 36 degrees is not a special right angle, that makes this triangle a SOHCAHTOA problem. So I'm going to list that SOHCAHTOA down here. That's sine, cosine, and tangent from a previous lesson. Okay, the two sides we're dealing with here are the opposite side, and this side right here would be the adjacent side. Alright, OA tells me to use tangent. So to find the apothem, we're going to take tangent of the angle, and that's going to be opposite over adjacent, which is our apothem. Now, if that variable is on the bottom, that means we're going to divide. So 4 divided by tangent 36 would give me my apothem. So let's go ahead and calculate that out. And if you do that properly, you get 5.5055, and it continues. Now, don't round that, okay? We want to store that in our calculator. Now I'm just going to keep that in my calculator and now just multiply it by the rest of the equation times 40 and then divide it by 2. And if you do that correctly, we get approximately 110.1, and that would be centimeters squared. Alright. Okay, the next example we have example 2, and this is a real world connection. We have the Castle del Monte, alright, which is in southern Italy, built in 1240. And what that castle makes extraordinary use of regular octagons. Okay, one regular octagon is the inner courtyard, and it has a radius of 16 meters. And we're going to use that to find the area of that courtyard. All right, so the radius, if you recall, is from the center of the shape to the vertex. All right, so this is my radius, and that's 16. All right. Now in this example, we don't have too much information at all. Let me do my work up here. Area equals 1/2 apothem times perimeter. So it's 1/2 the apothem and times the perimeter. Now, we don't know the side length and we don't know the apothem. Okay, so we're going to use this right triangle right here to figure out what the apothem is and hopefully figure out what the bottom of that triangle is so we can double it and then multiply it by 8 to get our perimeter. So the first step is to find that angle right here. So again, that's 360 divided by the number of sides and then divided by 2. Okay, so if we calculate that, we get 22.5 degrees. That is not a special right triangle. That's just it's a different right triangle, and that tells us since this angle is not 30, 60, or 45, we're going to have to use, again, sine, cosine, or tangent. So the first thing I'm going to find here is I'm going to find the apothem, okay? So I'm going to find this apothem right here. And the two sides involved here would be the adjacent, and this would be the hypotenuse. Now, AH in our SOHCAHTOA lesson was cosine. So we're going to take cosine of the angle 22.5, and that's going to equal the adjacent leg over the hypotenuse. Now, in this case, our variable's on top, so our apothem is going to simply be 16 times cosine 22.5. Okay, so when we calculate that, we get 14.78207.252. That's on my calculator. Now don't round that, because if you round that during the middle of the problem, you're going to have an inaccurate answer at the end. Okay, so that would be my apothem. Next, I'm going to find the bottom of this triangle down here so I can work on getting the perimeter. Okay, so to figure out that length, all right, this would be the opposite leg, and I'm going to use the hypotenuse again. So that's going to be sine of the angle equals opposite over hypotenuse. All right, so x is going to be, let's see, since it's on top, we're going to multiply 16 times sine 22.5. Let me calculate that. All right, so the bottom of that triangle, I got 6.122934918. All right, that's the length of the bottom of that triangle. Now, next thing I'm going to do is I'm going to take that side, and I'm going to multiply it by 2, because that would give me the whole length of that side of that octagon. So I'm going to times that by 2. All right, so the whole length of this side and every side is 12.2458698.4. All right, so finally for the perimeter, I can take that and I can multiply that by 8 sides. So I'm going to times that by 8, and that gives me the perimeter of 97.96695.869. Okay, now I have all the information. We have some pretty long decimals. You're going to have to type in some numbers here, but now I have the information I need. So I'm going to take that perimeter, going to multiply that by the apothem. And then I'm going to divide it by 2. And our final answer for the area is approximately 724.1, and this would be meters squared. Okay, so if you're given the radius and that's it, you're going to have to use sine, cosine, and tangent twice. Once to find the apothem, next to find the side of that triangle, then you're going to double it and then multiply by the number of sides to get the perimeter. So that was a little bit of work done there, but not at all impossible. Okay, last in this lesson, we're going to talk about another way to find the area of a triangle. Okay, one thing we know about triangles is that the area of a triangle is 1/2, all right, base times height. All right, now if you don't have all that information, there's another way to find that. It says right here the area of a triangle is 1/2, okay, 1/2 a side times a side times sine of the angle included between those sides. Okay, so in this case, if we know side C and we know this side labeled B and I know this angle here, then I can use what I call the side angle side formula for area of a triangle. So let's try an example for that. Okay, so in this example here, surveyor surveyed lengths of 2 adjacent sides of a triangular plot of land, and they are 412 feet and 386 feet. The angle included between those sides is 71 degrees. Okay, so this is my side B, this is my side C, and this is that angle A in between those sides. So the area of that triangle, we don't have base and height. All we have is a side, an angle, and a side. So it's going to be 1/2 that side B times the side C times sine of the angle A in between it. So we're going to plug in here. That'd be 1/2 412 times 386, and then times sine of the angle 71. And I can go ahead and just calculate that out. All right. So if we do that properly, got a pretty big plot of land here. I got 75,183.9 square feet. It's a pretty big plot of land. Okay, that concludes the notes. Hopefully you guys understood that, and we'll see you next time.